Hello everyone, and welcome to the Numpy operations lecture. In this lecture, we're going to show you basic operations you can perform on Numpy arrays. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, so here we are at the Jupyter Notebook. We'll go ahead and discuss array with array operations, array with scalar operations, and then some universal array functions, what they are, and how you can find more of them. We'll go ahead and start by saying import numpy as np. And then I'm going to go ahead and make an array. We'll say np.arrange. And let's just go ahead and go from 0, 11, so that way we get digits 0 through 10. So 11 digits from 0 to 10. Alright, you can easily perform array with array operations just by using simple arithmetic signs that you're already used to from Python itself. So for instance, if you wanted to add two arrays together on an element by element basis, you would just say array plus array, and that would add the two arrays together. In this case, I'm just adding an array to itself, so essentially every number's been doubled. I can do the same thing for subtraction or even multiplication. I can also perform array with scalar operations in very much the same manner. So scalars mean just a single number, and what NumPy does is it basically broadcasts that number to every element in the array, so that operation occurs also on an element by element basis. Meaning if I wanted to, here's my array, add 100 to every element in the array, I could just say plus and then the scalar itself. And that would add 100 to every element in the array. And this also works for multiplication, division, subtraction, you name it. So if I wanted to subtract 100 from every element in the array, I can just say minus 100. Alright, so those are basic arithmetic operations that you can perform with either array on array operations or array with scalar operations. Something I want to show you is that a lot of times NumPy will just issue a warning instead of outputting an error on certain mathematical operations. So for instance, if I try to say 1 divided by 0 in Python, I will get an actual error, a zero division error, which makes sense because you can't divide a number by 0. However, NumPy won't give you the same error. So if I try to say array divided by array, notice the very first element is 0. So I will try to say 0 divided by 0, which doesn't really make sense. However, NumPy will issue a warning. It will say invalid value encountered in true divide here. And it'll just give you a null if you try to divide a 0 by a 0. Everything else is okay. For instance, 1 divided by 1 is 1, 2 divided by 2 is 1 as well, etc., etc. However, on the very first one, 0 divided by 0, it executed and gave you a nan, or a null object, back. It didn't actually provide an error for you, meaning you still get an output. And that's important to note the distinction there. That means if you have this sort of operation in your code, you actually won't get an error, the code will continue to run, and instead you'll just receive a warning. If you try to do an operation that divides maybe another number by 0, so for instance 1 divided by 0 instead of 0 divided by 0, you'll also get a warning, but in this case it'll actually show infinity instead of a null. So again, you get a divide by 0 encountered in true divide warning here. However, it still executes the code, and you get INF to signify infinity for the 1 divided by 0 at that very first element. Alright, so that's something to keep in mind as you're working with division and arrays that contain a number or digit 0. And also a quick note is you can also do arrays with exponents by just saying asterisk asterisk, just like you would with Python, and then either the scalar or the array you want. So this is the array to the power of 2. So everything has been squared in the array. Now let's discuss universal array function. NumPy comes with many universal array functions, which are essentially just mathematical operations you can use to perform the operation and broadcast it across the entire array. Let's go ahead and show some common ones. For instance, if you want to take the square root of every element in an array, you can just say np.sqrt and then pass in the array itself. And this will take the square root of everything in the array. Similarly, for calculating the exponential, you can say np.exp and pass in the array. For maximum, you can either say the array.max, or you could also say np.max and pass in the array. That's the same thing as calling the method off of it, which we've seen earlier in the very first lecture on NumPy arrays. You can even do trigonometric functions such as sine, and this will basically pass in every element into sine. And there's cosine, and there's also logarithmic options, so you can say np.log. And if something doesn't work, for instance, the log of 0 is technically negative infinity, you'll actually receive a runtime warning divided by 0, but it will give you negative infinity as the answer. If you're wondering where you can find a list of all these universal array functions to reference, you can go ahead and check out the notebook, and it has a link in there for the universal array functions, and it will take you to a link that looks like this. This is the NumPy array documentation here for universal functions, or ufunc. And if you scroll down to the bottom of this page, and again this link is in the notebook for this lecture, NumPy operations, you'll see a whole list of all the universal functions you have available for you. So you have basic math operations, add, subtract, absolute, remainder, etc., log, trigonometric functions, and then some more advanced functions, such as comparison functions, maximum, minimums, floating functions, etc. If it's a very basic or common mathematical function, you should probably visit this page first and see if NumPy already has it built in before you start creating your own function to deal with that particular mathematical operation you were trying to perform on your array. We'll only deal with the very basic ones throughout the course, and we'll remind you as we encounter them throughout the rest of the course. Okay, that's really all there is as far as basic operations on arrays. You can just use basic arithmetic either on an array by array basis or with an array and a scalar basis. The only thing to watch out for is if you have a 0 and you're using division with your arrays. Then the second part of this lecture just covered universal array functions, where to find them, and to keep in mind that most common mathematical operations are already built into NumPy. Okay, thanks everyone, and I'll see you at the next lecture.